Hello everyone, my name is James Nicholson, and my final project for CSCI S89 Introduction to Deep Learning is multi-class image classification, transfer learning for standalone convolutional neural networks. For many years, the gold standard for multi-class image classification problems has been the convolutional neural network. To successfully train a convolutional neural network, however, a large amount of data is needed. Transfer learning, on the other hand, involves using a pre-trained model and training the final layers on a new data set. This allows the new model to use knowledge already learned by the pre-trained model and requires a lot less data than training a model from scratch. My problem statement is, what is the performance gain realized from using a transfer learning model versus a model trained from scratch, given that the two models are trained using the same data set and roughly the same hyperparameters? The data set I use to train my models is called 70 dog breeds. It's a data set of 7,946 training images, 700 test, and 700 validation images. Dimensions being 224 by 224, and they are RGB. To answer the question defined in my problem statement, I created two convolutional neural networks, one using transfer learning and the second not using transfer learning. The transfer learning model is built on top of the Inception v3 image recognition model, using all but its final output layer. The pre-trained Inception layers were frozen, and multiple fully connected trainable layers were added. The non-transfer learning model uses no pre-trained layers and employs a fairly typical architecture for image recognition. Both models were trained over 30 epochs with the dog breed dataset described before. I now want to take the opportunity to give you a walkthrough of my project notebook. And I'll also talk a little bit about how you might run this notebook yourself if you were to download the notebook and upload it to Google Colab. One important thing to note is that this implementation was developed to be run on Google Colab, so it could be run locally if some modifications were made, but sort of one constraint of this is that it was really developed. It uses some specific tools that are available on Google Colab, and as a result, it was developed to be run here. Up front, there's some required configuration. You have the option of using either Google Drive or the Google Colab local storage as the file system. And the reason for this is it allows you to save the models once they've been trained, which obviously takes a lot of time. That can then be loaded very quickly without having to retrain the model every time the Google Colab notebook gets disconnected due to idle timeouts, which happens pretty frequently. So all the instructions are here, but basically you decide if you're going to use Google Drive or the local file system. And if you're going to use a Google Drive, you have to specify which directory you want to save items to in your Google Drive. Then there's also a couple constants here to basically turn on or off training the models if you were just run the entire notebook. If you set this to false, then it's going to attempt to load the models and their histories from whichever file system you selected. And if you set them to true, then obviously it's going to just retrain the model and resave the models and the histories to the file system. Another requirement are Kaggle credentials to download the data set. which is automatically downloaded and extracted below. And there's instructions for how to do that here. So once all of that is taken care of, we can get into the interesting parts. So to actually create a transfer learning model is a pretty simple operation. Um, I'll go down to the model build section here. Um, and as you can see here, I'm just creating an Inception v3 Keras application, which is using the ImageNet weights. And once that's created, you want to also specify that you're not including the topmost sort of final output layer, because we're going to create some layers in place of that to train, and that's kind of how transfer learning works. You also set this entire base model, this entire inception model, as not trainable. That way, all of those parameters are frozen and they won't be updated during training. Because all we really want to do is train the sort of additional fully connected layers that we're adding here. And so that's really the gist of how to create a transfer learning model. And then I'll jump down to a little bit further down, creating the regular convolutional model. So yeah, similar sort of data preparation and pre-processing. But for this model, you can see here, since we're not using a pre-trained, pre-built model provided by Keras, we're sort of creating it from scratch. There's a lot more involved here in building this model, and it actually took more time to just create this regular convolutional, model here from scratch than leveraging transfer learning and the inception model. And I think that's one of the reasons why transfer learning is becoming so popular lately, is because it just requires a lot less work and a lot less architecting and fine tuning, because a lot of that has been already done by very experienced, very smart people. And so once this was created, it was trained and tested. And let me actually go through some results for these two models for a moment. Going back to the transfer learning model, let's see. We can see here that after it's trained, it's successfully able to, identify dog breeds, just sort of anecdotally with these three images here, randomly chosen. And I'll be going more into analyzing the results later on in the presentation, but you can just see here that one interesting thing here is the, after evaluating on the test data set, which is about, I believe, 700 images, it had 100% accuracy for the top K categorical, which means, and K in this instance is 5 because I use the default amount. That means that for every image it was given, its top 5 predictions in terms of probability always contained the correct image. And so that's pretty impressive. If we go down and look at the regular convolutional model for the same metric, we can see here that the top K categorical accuracy is 65%. So that's just one way of looking at the performance of these two models. There's obviously some graphs here that I'll show later in the results section. Um, so this is the notebook and the implementation. There's obviously a lot more here that I can't cover in this presentation, but if you take care of those configurations and requirements up at the top, you should just be able to run the notebook and it'll train and visualize the performance. As I mentioned in the code walkthrough, uh, I have some other results to show for the transfer learning model versus the non-transfer learning model. Um, so just in the bird's eye view of these two, it's pretty obvious that the transfer learning model vastly outperformed the non-transfer learning model. Um, I think the comparison of the top K categorical accuracy that I mentioned earlier is pretty stark. Um, and looking at the um, training and validation loss here, um, the, the validation loss for the non-transfer learning model is much higher, about 3 times as high once the training was done. Um, and in terms of accuracy, um, the transfer learning model is about twice as accurate, um, just in terms of pure accuracy. So I think using these metrics seen here, both in training and validation, and during the test evaluation, um, it can be reasonably concluded that um, transfer learning, at least in this example, uh, using the inception image recognition model versus just a trained from scratch convolutional neural network, transfer learning is much more performant, and that's not surprising. We are talking about a a very skillfully architected um, Inception v3 model that was trained on millions of images, and we're sort of piggybacking on that. But it's interesting to see the results here in these visualizations. So reflecting on this project, I want to talk a little bit about what worked, what didn't, and some of the lessons learned. Um, Implementing a transfer learning model was actually a lot more straightforward than I thought it would be. Um, Looking back, this makes sense because it's basically taking a model that's already 90% built and just finishing off the last 10%. Um, Developing the two models in Colab really sped up my development process because of the GPUs I was able to take advantage of that I don't have on my MacBook Pro. Eventually, though, I ran out of compute units and I had to pay $10 for another batch, which, in my opinion, was worth every penny. Um, some things that didn't work. Colab solved some problems for me, i.e., the training time, but created others. Due to the ephemeral nature of Colab environments, I would frequently be disconnected from my runtime and would have to rerun my notebook to continue developing. I would lose all the time spent training and the variables and state that I had already accumulated. This is why I eventually implemented saved models and histories in Google Drive so that those that state could be persisted, and to remove the slow processing culprits from my script while I was developing. Um, if I were to do this project again, I would look for a better cloud-based notebook platform. I want one that was more developer friendly, that had a more developer friendly idle session policy, so I wasn't constantly losing my notebook state. That concludes my project presentation, and I want to thank you for listening.